So this lesson is, we're going to end up using the proportions we learned a couple lessons ago to help us identify when we know two polygons are similar, we're able to find a missing side. What if you've got, all the information, but you're missing one side length? But as long as the polygons are similar, then you're able to use proportions to help us find out what that missing side length could be. So if we look at this particular example, again, one of the pieces that I want to really reinforce here is that labeling piece here to identify which sides correspond with which sides. If I'm looking at AB, this piece here, it's going to correspond with EF, this chunk here. And same thing, BC from here is going to correspond with FG from here, and so forth. You can go around your polygon that way. Same thing with the angle measures. If I'm looking at this and seeing that angle D is 80 degrees, that's this one here, well, that would mean it corresponds with angle H. If we were asked to find the measure of angle H, and this is all this on your computer, sometimes we have to use this to represent an angle measure. It sometimes looks more like that in real when we write it. So if you're asked to find the angle measure of H, that's this here. Well, it corresponds in our labeling process to D. So this would be 80 degrees. Determining the angle measure of G, well, G here represents and corresponds to angle C, which in this case is 100 degrees. And so then what we're asked to find is, let's determine the length of side GH. Well, GH is here, this piece right here that we don't know. So what we want to do is, we have been given other valuable pieces of information. So if I look at this distance from D to A here, that is going to correspond from H to E here. So we know these ratios, this is similar. So this ratio is going to be equivalent to this ratio down here. So meaning, again, so now we're back to not establishing scale factor with these. So it really doesn't matter which figure you start with, just be consistent. So if I'm going to start in this figure and pick this side relationship, and I know that relates to the other side relationship in this one, then I want to make sure, and I'm going to set this equal, and this is where we're going to create that proportion now. I'm going to come back here. This side relationship of 15 is going to equal, I've got this GH, this is my missing piece that I'm trying to find, right? That's the piece I don't know about yet. So I can go ahead and cross multiply here. So I can take the 12 times that GH, that's the piece I'm trying to find, and it's going to equal the 8 times the 15. So this brings in that whole solving these proportions using cross multiplication. I'm going to take the 8 times the 15, which is going to give me 120. So I really have 12 GH is equal to 120. I'm going to divide by this 12, and I am going to be left with that GH, that missing side that I don't know yet, is equivalent to 10. So I've just used my proportions to help me solve for that missing side. All right, so I've got, we've seen this question in previous lessons, but now we can actually address this width of X centimeters down here. So Mary's scaling down a pattern for a skating outfit to make a smaller size. So she's using this larger piece to scale down to make the smaller rectangle piece here. So we know the side length here is 20 centimeters and the width is 6 centimeters. And the smaller version is 4 centimeters by X centimeters. We want to identify what the value of X, what is X going to be? So we can set ourselves up a proportion same way. Is I can look at this and go, okay, so X is what I don't know. So X corresponds to this width over in the original. So again, doesn't matter which ones I start with. I can start with the X, my missing side over here, which corresponds to my 6. And I can set that equal to, because I'm setting these proportions equal to each other. I know these two shapes are similar. So that means their side relationships, their side ratios are going to be similar and equal. So in this case, since I started with the X here, I'm going to start with the 4 for my other side relationship, and that's over 20. So now, once I get my proportion set up, I can do that lovely cross multiplying. So I can take 20x is equal to 6 times 4, which is 24. So if I want to divide both sides by 20, I'm going to get 24 divided by 20, and I'm getting that this width of this new rectangle is going to be 1.2 centimeters. Please make sure if there's any units, please include the units where possible. If they're included, then make sure your answers have them as well. Okay, so given that the two figures below are similar, let's determine the values of X and Y. So this time we have 2 missing sides we want to find. So that can be a problem if we don't have a complete set of corresponding sides that have 2 values. But in this case, we have this 12 here, and it corresponds with the 7 over here. So that is going to be very helpful in us creating our proportions. Now, when we do this, since we have 2 variables, 2 missing sides, we essentially have 2 questions we have to figure out here. So 2 separate proportions. So what I can do is use this 12 and the 7. So I can say 12 over the 7, create that first ratio. And I can say, well, I'm going to I want to figure out what X is. Let's figure out what X is first. So that means I need the corresponding side to X. So if this side here is X, its corresponding side is 14.5. So I'm going to start with the 14.5. I'm going to start from this one because I already did with the 12 over 7. And I'm going to put my X in. So I'm back to, again, cross multiplying. So I'm going to get 12x is equal to, and I've got that 7 times 14.5. So 7 times 14.5 gives me 101.5, and that's what's going to equal 12. And then I basically want to take and divide both sides by 12. And I find out that X is going to equal 8.45. Again, if I want to round this to one single decimal place, I'm going to say 8.5. I'm not given units, so I can leave it as that. So all we did here, though, is just found out what X is. So now what I want to do is create a proportion this time that I'm able to use and include Y in. So same thing, I'm going to use the for sure side that I have both values for. So 12 over 7, I'm going to use those corresponding sides. And then this time, instead of using the X, I'm going to use the Y and its corresponding side. So the Y, since it's over in this first shape, I'm going to put the Y on top, and it corresponds to the 2.5 in the other one. So same thing, I'm going to go through, do my cross multiplying. So 7 times the Y, and I've got the 12 times the 2.5, which this works out to 30. And now if I take that 7 and divide both sides by 7, I'm going to take the 30, divide by 7, and I'm getting Y is equal to 4.28. But again, if I round that to one decimal place, that's going to work out to 4.3. And again, no units of measure, so we don't have to include any units of measure there. Okay, let's try the next one. This time we're trying to find Z. This is our missing value right there. So same thing, we have to look for corresponding sides. You want to create that proportion now of what corresponds to what. So right now I have Z, and it corresponds to, looking at just the shape and what we're looking at, these look like they're flipped, but at the same time, these look like they're corresponding. Okay, JK to QP. So in this case, I'm going to have Z over 10. That sets up that particular ratio. And because I started with Z here, then I'm going to have to start in the same shape with my other piece of information that I have, which is 6. And it corresponds to the 15 in the first shape. So same thing, I am going to do some cross multiplying. So that's going to leave me with 15Z, and 6 times the 10, which is going to give me 60. And if I divide both sides by 15, I find out that Z is equal to 4. So that missing piece up here, the side length, is actually equivalent to 4. Again, no units of measure, so I don't have to include the units of measure. So the next and last example that we have, there's a few things. We've got several variables that are happening here. We've got X we need to find Y, and it looks like we need to find Z. So these are similar shapes. So now we have to look at, how do we find these missing variables? So looking at just the angle measures right off the bat in this case, looking at your shapes and recognizing, and maybe I hope you identify that this here corresponds to this angle measure here, just by looking at basic shape and size and looking at the structure of the actual shape. So in this case, we know Z is going to equal 115 degrees. Now, the other pieces we have to account for is we have to find X and we also have to find Y. So when I look at this, I start to think, which sides correspond here? What am I working with? Because if I have to find X, I better have a set of corresponding sides that have no variables in them. So in this case, if I'm going X, this corresponds, it looks like, to this piece right here. So in this case, I'm setting up X over 25 because I know they correspond together. Y down here, it looks like it corresponds with the base of this one. It looks like these two have just literally been flipped over, right? So the bottom here is going to correspond with this bottom here, and this top here is going to correspond with this. So because there's a Y down here, I can't set that equal to my proportion with my X in it because I'm never going to be able to just solve for X. So I need to find that other corresponding relationship of sides. So in this case, I'm looking at the 18 and the 30. They correspond, and there's two values there. There's no variable there, so that's a good thing. Since I started with X from this first shape, I have to start with the 18, and that's going to be 18 over the 30. So now I'm back to doing my cross multiplying to find out what my value of X is. So I've got 30X, and I'm going to take that 18, and I'm going to times it by the 25, and I am getting 450 for that is equal to 30X. So then I'm going to take and divide both sides by 30, and I get that X is equal to 15. So that's to find my X, but I still have to find my Y. That's my other piece that I need to find. So in this case, if I start with my Y and it corresponds to the 15, I can take that Y over 15, create myself a fraction there, and then I'm back to, again, coming up to these corresponding sides. But take note, this time I'm starting in this second shape. So now I'm going to start with the 30 on top, and it corresponds with the 18 that I'm going to put in the bottom. So now I can go ahead and cross multiply, which is going to give me 18y. And I am going to take the 30 times the 15, which works out to 450. Still, that didn't change. And I am going to divide both sides by the 18. And I'm getting y is equal to 25. So this one had a little bit more complexity to it. We had finding both x and y, but we also had to find that corresponding angle measure as well. And that is it for finding missing side lengths in similar polygons. Now you can go work on some practice.